this part we are going to learn about linear data structure. Elements connected in linear fashion by means of logical or in sequence memory locations. There are two ways to represent a linear data structure. Those are static and dynamic. Here are examples of linear data structure: stack and queue. Array. We know about array. What is the array? Array is a collection of elements of the same data type. Arrays store a data in a consecutive locations. That's why random access in a constant time is possible. In array, we use static memory allocation. That's why we pre-allocate the size of array. Here is an array. In this, 1, 2, 3, 4, 5, 6 and 7 are data. This 0 to 6, that is called index, and 100 to 106, that is called address. This is example of address that is different in a computer. Now, what is the stack? A data structure in which insertion and deletion operations perform at one and only. A data structure in insertion or deletion is performed at the one and only. Insertion operation is called push operation and deletion operation is called pop operation. Stack data structure is also called LIFO data structure because in this data structure, last in first out, which data is inserted last, that is deleted first. That's why it is called LIFO data structure. The meaning of LIFO is last in first out. That's why stack is called LIFO data structure. Here is empty stack. In empty stack, we doesn't have any data in the stack. That's why here top is equal to -1. Here top is here, that is -1. This is a full stack. We can insert a data by push operation. Here top is at the first position and top is equal to 7. Let we count. This is 0, 1, 2, 3, 4, 5, 6 and 7. So that's why it is top is equal to 7. We can delete a data by pop operation. By doing pop operation, we delete this data from the stack. structure in which insertion at one end and deletion at another end is called queue. In stack, we do insertion and deletion operation at same end, but in queue we do insertion and deletion at different end. If we insert this type side, so delete this side at the end which deletion is occur is known as the front, and another end which insertion occurs is known as rear end. Queue is also known as a FIFO data structure. This is called first in last out because insertion and deletion are not doing at the same end. That's why here is a queue. This is the rear point and this is the front. We insert a data from here and we delete a data from here. We want to insert a data 6 at here, this point. This operation is called enqueue, and we want to delete data at this point. This operation is called take. Linked list. Linked list is collection of objects stored in a list form that is shown in the name of this data structure. Sequence of items where every item is linked to the next item. We use dynamic memory allocation. Linked list is also called a nodes, and nodes contain two parts. That is, one is a data part and another is pointer part. So obviously it has two parts, that's why it's required more memory compared to array. Here you can see this is the node. In node, this part have information and this part have link. This is called a data and this is called pointer to the next node. Here are types of linked list: singly linked list, circular linked list, doubly linked list, doubly circular linked list. We'll learn about it deeply in the next.